Okay, guys, in your class, we are picking up where we left off. And that is, we had just finished the front page yesterday. I believe right before the bell rang, we finished part C on example 2 yesterday. So we're ready to do the second example in example 2. So, tried this process yesterday. Now it's time to kind of review the process, make sure we can figure it out. Notice what it says. Suppose x and y vary inversely. And x equals 8 when y equals negative 7. A is asking, what is the function that models the inverse variation? So right there, they are telling us we are talking inverse variation, right? So, flip back. What are my inverse variation formulas we were talking about yesterday?
Y equals K equals y equals K over X.
Okay, one of them was y equals K over X. What's the other one?
Y times X equals K.
Okay, xy equals K, K equals xy. Those are the two equations that we were working with when we talk inverse, right? So, we're being asked to find a function that represents a situation for an inverse variation when x is 8 and y is negative 7. What do we do? Okay, take x times y to find k. Right there, it says xy equals k. So we're going to do 8 times negative 7. And so what do we know? K is negative 56. Okay? If K is negative 56, what is the function that models this inverse variation? What was it? Okay. So if we're filling in y equals k over x, it's y equals negative 56 over x. Okay. I would also be okay. What's the other one you could possibly say? xy equals negative 56. That also is a function that models the equation. Y equals is more the normal response, okay? Y equals negative 56 over x. Are we okay with A? Some of you said you made it through A on your own. That was doable. Okay, let's talk B. What does the graph of this function look like? What did my graph on the front side look like yesterday? Curve? How many curves? Officially 2 curves, yes? We had the curve in the first quadrant, so up there to you guys, right? And then we had one in the diagonal quadrant, so down quadrant 3. Okay? So, how did we figure out some points for this curve? Yeah. It said officially you could use either of the two equations. You could use y equals negative 56 over x, or you can use the idea of xy equals negative 56. And the way I took you guys was, okay, xy equals negative 56. Pairs of numbers that multiply to be negative 56. Yes? What?
What do we different? There's different symbols.
What do you mean we can't use? The one we did yesterday came up to be in quadrants 1 and 3.
I thought you were saying.
No, it's not that. It's just the graph we did yesterday. The numbers that make it work, put it in quadrant 1 and then the diagonal quadrant, which is quadrant 3.
I got it.
Okay? So it's going to vary depending on the situation. But it will always, in a typical problem like this, it's going to be diagonal quadrants. So, and you'll see what happens on this one here in a moment. Okay, guys, we officially need numbers that multiply to be not just 56, but negative 56. So, let's just worry about numbers that multiply to be 56 to begin with, but we'll tag a negative on there. So, if I start with, I like to start with 1. 1 times what? 56. Now, in order for it to multiply to be a negative, we have to have one of our two numbers being negative. So, for right now, I'm going to say 1 times negative 56. Does 2 go into 56? Yeah, 2 times what? 28. So, it's going to be 2 times negative 28. Does 3 go into 56? It doesn't. If you're not sure, 56 divided by 3 in your calculator, right? 4? 4 and what?
14.
So in this case, I'm going to say 4 and negative 14. 5? Definitely not. 6? No, because 3 didn't go. 7? This one you should know. 7 and what? Negative 8. What about 8 then? Now we're at the point that we are reversing our pairs, yes? So if 8 and negative 7 works, the next pair that I'm going to reverse, 14 and negative 4. And I'm going to have to reverse 56 and negative 1, 28 and negative 2. Now, I don't know about you guys, but these are all good numbers. I'm probably not going to actually physically graph what? Definitely the 56. Not going to graph the 28 either. Does that still leave me some decent pairs? It does. It leaves me 4 decent pairs, and we're already going to know the shape, right? It's those curves that are curving out and away from the x-axis. Now, do I have all the points I need here? Why not? Okay. The pairs that we just gave have all the x's always being positive and the y's always being negative. What's the other option? X is always negative and y is positive. So if we just look, I'm going to say and here, so we're going to need some more numbers to make this work. If we just look at the ones that I'm actually going to graph, instead of positive 4 and negative 14, I need to say negative 4, positive 14. Instead of positive 7, negative 8, negative 7, 8. Negative 8, 7. Negative 14, 4. Okay, and not that we couldn't do that with the 56 and the 8s, or excuse me, 56s and 28s, but I'm actually going to graph those. So now, with this one, what I'm actually going to do, and you can do it this way or not do it this way, I'm going to take my current grid and I'm going to break it in half. So I'm just going to redraw my axes because that'll be easier for me. You guys can graph it how you want, but I'm going to basically go to these 10 lines and draw a new set of XY axes because are all my points in that first axis, or in that first quadrant, I mean. It is not. So I'm going to do that. Okay. You're welcome to walk up and grab a ruler if you feel that desire. You're welcome to freehand if you feel that desire. Okay? You may have already made this work a different way, right? Okay, guys. So, 4, negative 14 says we go where? Over 4, down 14, which That bottom line should be negative 10, I believe. I don't know, ballpark area there. Okay. 7, negative 8 says right 7. Down 8. 8, negative 7, so right 8. Down 7. 14, negative 4, so right 14. Let's see. I think it's in that ballpark area there. Yours looking somewhat like this. If we connect those, can you still see that same shape? It's running down in that lower right quadrant, and it's never going to cross what? Your X and Y axis. Okay? What quadrant number was I just in? Quadrant 4, right? So remember 1, 2, 3, 4. 1 is top right, you go counterclockwise. So that's quadrant 4. Where's the other piece of this in? Quadrant 2? Why am I in quadrants 2 and 4 this time instead of 1 and 3? Because it multiplied to be a negative, right? So I need to be in quadrants where I have a 1 positive and 1 negative quadrant, or coordinate, excuse me. Okay, so get your others drawn too. Okay, and I'm kind of ballparking it. You get the idea, yes? You get your graph finished up, take a peek at C, and get C answered. What is y when x equals 2? How do we find this? Yeah. Officially, what will always work is to put into the equation, yes? We came up with this equation up in step A that says y equals negative 56 divided by x. So you can put it into that equation. Now, in all technicality, this is one of our points from part B, isn't it? So you could grab the number from part B. But negative 56 divided by 2 when x is 2, and that is negative 28. When we did it yesterday, it came out to be a decimal. It was not one of our ordered pairs. Okay, guys, this is our inverse variation. Talk about it in lesson 8.2 actually by a different name, but for today it's inverse variation. Questions on anything there? Okay, let's take a little bit of time to look at combined variation here. In other words, I'm still talking about direct variation, I'm still talking about inverse variation, but we're also talking about joint variation. Okay, and joint variation is really just the idea of putting maybe a direct and an inverse together, or multiple directs together, or something along those lines. So, we already know. Okay, so review here. If I say direct variation, what is the y equals equation for direct variation? It is what? Y equals k times x, right? So when we talk direct variation, it's a constant times the x value. When we talk inverse, what's the difference with inverse? It's y equals k over x. So it's a number k, a constant k, divided by x. Okay, so lock those in your head. Direct is multiplication. Inverse is variation. I'm not talking how we find k, but how we represent the equation. Now, the idea right here, when it says z varies jointly with x and y. Notice, z varies jointly with x and y. Notice what it says. It's z equals k times x times y. What is this basically a bigger example of? Direct. Okay, the idea here is z varies jointly with x and y. Instead of just saying z varies directly with x and z varies directly with y, it's varying directly with both of them. So when you see that word jointly, it's going to be, you're going to want to basically think directly. Okay, being that it's going to be that k times whatever variables that you're varying jointly with. Okay? And so thus, z equals kxy. Okay, the next example says z varies, what are my words here? Jointly with x and y and inversely with w. Well, jointly is another word for thinking what? Directly. So that's saying z varies directly with x and y and inversely with w. Meaning, so direct variation, what do? We have to multiply by k, right? Inverse variation, we have to divide. Notice right here, z varies directly with, jointly with x and y. So notice z equals kxy. And inversely with w. So what do you do with the w? You divide by w. Okay? So directly or jointly, you're multiplying those things by k. Inversely, you're dividing those pieces. One more example. Z varies directly with x and inversely with the product wy. So do you see it here? Z varies directly with x. What's that mean that we're going to do with x? It's going to have to multiply by k. Inversely with the product wy. So what's that mean is going to be happening with, if it's inversely, wy is going to be divided. Okay? Direct multiplication, inverse is division. Got it? So that's what's going to help us write the statements we need to answer the next problems. Okay. We're going to use this information to help us in example 4. Now, there's a typo in this one. Where is it?
It says z varies directly with a.
Right, well, they're using different variables here, but then what it is down here they randomly throw in an n. There is no n in this problem. Don't throw an n at me. This is supposed to say z. That's where the typo is. I knew there's something wrong. I just can't remember what. Okay. So, let's read it. Z varies directly with A and inversely with W. If A equals 36, when Z equals 2 and W equals 3. What is Z when A equals 90 and W equals 3? Okay. Reread it if you need to. I'm going to break this down into pieces. First statement only. I want to write the equation that represents this problem. Z varies directly with A and inversely with W. I want an equation that represents that statement. Z varies directly with A and inversely with W. What do you think?
You just put Z in that or Z.
Right. Okay. So first of all, and that's what I need to point out, it says Z varies. That word varies kind of acts as your equals there. Okay. So when I say Z varies, that to me says I'm going to say Z equals. Now, directly with A. What's directly say we're going to do? Multiply. So we're going to multiply with A. Inversely, what's inversely say we're going to do? Divide. Okay, and because it's direct inverse variation, we have to throw in a constant. What do we use to represent our constant? The K. So, Z varies. Z equals. Directly with A means we're going to write what? K times A. Inversely with W means we're going to divide by W. This is my starting point in my mind. Questions on my starting point? Because if I've lost you already, this is going to be a really difficult problem because you can't really proceed. Okay? Okay, let's speaking up. Now, we're going to do the middle part next. If A equals 36 when Z equals 2 and W equals 3. Don't even continue past that. If A equals 36 when Z equals 2 and W equals 3. What can I find with all of that provided information that I just put in those brackets? Yeah, if I know an A, a Z, and a W, that means I know everything in my equation except K. So this second set of information, they're providing it to us so we can find K. We can find our constant. So, let's do it. So I'm going to use Z equals KA over W. Plug your stuff in, do the math. Z is 2 K times A, K times 36 divided by W, which is 3. Okay, 2 equals K times 36 divided by 3. Options to solve this. There's two different directions I could go here, so.
Multiply both sides by 3.
Okay, multiplying both sides by 3 will get rid of the fraction, the denominator. So if we do that, so then I'm going to have 36 times K equals 2 times 3, which is 6. If 36K equals 6, what do I do? Divide by 36, right? 36K equals 6. Divide by 36. I'm going to leave it fraction form here. Don't tell me a decimal, please. Divide by 36. 6 divided by 36 reduces to be 1/6. So what I have right now is my K value. Are we okay with that? I took that provided information, I plugged it in, I found a K value. Now, the next part continues to say, what is Z when A equals 90 and, I'm going to copy this from down below, W equals 3. That's just on the next line, right? I'm just putting it all there so I have it all together. So now, final part here. What is Z when A equals 90 and W equals 3? You see where to go here? Put in the numbers. So we're going to put A and W in and the K we found. Okay, so in actuality, I'm going to write my basic equation that it was Z equals KA over W. So that means now my equation is Z equals 1/6 A over W. Technically, I should go better form than that, but I'm not going to mess with it. Okay. So Z equals 1/6 A over W. We're plugging in A and W, which means Z is 1/6 times A, which is 90, divided by W, which is 3. Do the math. 1/6 of 90. How do I do 1/6 of 90? To do a sixth of something, you're dividing by 6, right? 90 divided by 6 is, it's nice, 15. Oh, this problem just became easy, right? And 15 divided by 3 is 5. Final answer, 5. Officially, yes, it is a Z. My Z equals is just way over here for whatever reason, but okay, did we follow that a little bit? For some of you, I went painstakingly slow, sorry. For others, I'm hoping I went the right pace. It's one of those things, you have to break these problems into pieces. If you read this and try and do it all as one big problem, you're going to get things confused. So, okay, let's try it again. Let's try B. Z varies jointly with A and D. If A equals 120 and Z equals 10 and D equals 3, what is Z when A equals 200 and D equals 4? I don't know about you, but when I read it like that, it's a blur of information. That's even me, the math teacher, saying that. So, break it down. What's the first part I need to think about here?
Varies jointly with A and D.
Okay. Let's just write an equation that we can use throughout this. Z varies jointly with A and D. Z varies. What's that tell me? Varies, I'm going to use the word equals. So Z equals. Jointly is a lot like the word what? Directly. And directly or jointly means we're going to multiply. So to vary directly or jointly with A and D. What am I going to do? Multiply A and D by K. You have to remember to throw that constant in there. So my starting equation is Z equals CAD. Z equals K times A times D. Good? Okay. Middle part. Don't go all the way and read this all as one, because it'll get too confusing. Because they give you what? 2A values, 2D values. You're putting too much information together if you got more than one of something. So just if A equals 120 and Z equals 10 and D equals 3, comma. Okay, I'm going to stop there. So, I know Z equals CAD, Z equals K times A times D. What am I doing? Solving for K. Z equals 10 equals K times A, which is 120, times D, which is 3. What's going on? K times 120 times 3. Okay, so 10 equals 360 times K. To solve for K, I'm going to divide by 360. What is 10 divided by 360 as a fraction? 1 over 36, because what's the shortcut here? I can. Are you okay with the shortcut that I can cancel off a 0 here? So it's 1 over 36. Okay, there's my K. So what do I use to begin the next problem now? Or the next part of it? We're going to use that Z equals CAD, but instead of Z equals CAD now, my equation is officially Z equals 1/36 A times D, because my K is now A times D. What's this final part? Okay, yep. What is Z when A equals 200, D equals 4? Fill them in. So, we already know K is 1 over 36, A is 200, D is 4. If I do a cross-canceling step, I don't know, would you guys like that or not? What do you know about 4 and 36? They can both divide by 4. So that 4 is gone. 36 becomes a 9. What am I left with here? 200 times a ninth, which is 200 over 9. I personally am fine with that. If you divide it out, 9 goes into 200 22 times with 2 remainder, so 2/9. Or your decimal answer, 2/9 is 0.2 repeating, so 22.2 repeating. I honestly don't know what Math Excel is going to want. Okay? They won't do 22 and 2/9. I've never, ever seen them want a mixed number. I'm not personally against to it, but I would never see Math Excel want that. At least I don't think I've ever seen them want that. Okay. One more. This is more these are word problems we've just been doing, but this is more the word problem application, right? Let's do it. The volume of gas varies directly. And right there's your connection, folks. When its temperature, that's supposed to say, wait, what? Okay. The volume of gas varies directly with its temperature and inversely with pressure. Volume is 100 meters cubed when the temperature is 150 Kelvin and the pressure is 15 pounds per centimeter squared. What is the volume when the temperature is 250 Kelvin and the pressure is 20 pounds per centimeter squared? Okay. I'm going to do step 1 again. This is technically, I don't know if you guys see it, this is no different than the last 2 problems I just did. It's the same exact process, just more words. We've got the science connection here. So, first sentence, we're going to write an equation. It might be a familiar equation to some of you, I don't know. The volume of gas varies. Thoughts? Volume of gas varies. V equals, okay, volume of gas varies, so V equals directly with temperature. So what's directly with temperature say? We're going to multiply with temperature, which I'm going to call T, and inversely we're going to divide, and it's inversely with pressure, which is P. So V equals directly with temperature means KT, inversely with pressure is divided by P. There's what you need to get yourself started. From there, they give me some information. Look at that next sentence only. Don't go all the way. Volume is 100 meters cubed. So what are we putting? V is 100, yes? When the temperature is 150 Kelvin. So that is my T. And the pressure is 15. Do we have information to plug in? Yeah. Using that V equals KT over P. V is 100. K is what I'm trying to find. T is 150. Pressure is 15. So, like last time, actually, last time I think Ross had us multiply by 15, yes? Another option here, what's 150? 150 divided by 15? 10. Could we do that as well? Both work. So you could say 100 equals 10K. If 100 equals 10K, then what do I know? Divide by 10, and K equals 10. Okay. Write your equation to finish this problem off with. V equals KT over P is now V equals 10T over P. And what is the question? What is the volume when the temperature is 250 Kelvin and the pressure is 20? So fill it in. V equals 10 times 250 divided by 20. Ends up being 5 times 25, which is 125. This is volume. How was volume labeled in this problem? Meters cubed. Okay, guys, your homework is in Lesson 8-1, Math Excel. Get it done for tomorrow, please. Don't forget to bring pies if you want to eat pie tomorrow.
Not.